Good morning, everybody. I'm Domenica Borra. I'm a postdoc researcher at the mathematics department, and I'm working with Professor Fagnani at the mathematics department, and here with Claudio, Roberta, and Ennio. My background is in pure mathematics. I worked on recursive sequences and cellular automata. Actually, this is just computational algebra. And then I switched to applied mathematics. So during my PhD here at Politecnico, I worked on opinion dynamics models. All this stuff is related to dynamics over networks on different applications. The main focus was on camera networks. We faced localization and optimization problems. In particular, the cameras were had just the relative poses, and we wanted to define consensus protocols to find the absolute pose of the cameras. And in general, the research topics I'm interested in are related to distributed optimization algorithms, but also information theory, cryptography, and in general, everything that is related on graph theory and dynamic systems, with a special focus on cooperative multi-agent systems. As you probably already know, the applications may be various, for example, from the technological point of view, the web, or just robotic coordination, but also human beings and biological networks. Here at Swarm, I've been working on mainly three activities. The first two are related to the energy framework. The first one was with the goal of design a distributed algorithm to suggest optimal energy schedules for users. And the second one was a specific, part of the first, meaning that we wanted to forecast the pattern of the behaviors to give a very good suggested schedule for users. And the last activity was related to the consensus of a very simple robotic system, and I've been talking about them. So the first one was in the framework of the European project Intrepid, and the goal was to find such distributed algorithm to find and suggest the schedules. So the tools were, first of all, formalize the optimization problem, then relaxed with the technique of Lagrange multipliers, using also meta-heuristic techniques, and a global mechanism involving reward and reputation to give incentives to users to follow such suggestions. And we found empirically and numerically that an emerging cooperative behavior was coming out. In the second activity, we apply different existing methods in literature to our problem to predict the pattern of behaviors. This came from topic modeling and image processing, and also a simple time series analysis, for example, the Poisson process with time varying rate. And with machine learning techniques and Bayesian inference, we want to find the distribution, the probability distribution of the behavior of users, such that we can suggest the most comfortable schedule for the consumption. And finally, the third activity was to, we wanted to find the mathematical model and to study the convergence analysis and also the numerical evidence of this system. We have this very simple system of robots running through a closed circuit, and they were just following a random direction. They crashed just a couple of them each time, so we have a randomized gossip algorithm, and with some probability they turn around. And finally, we found that they converge to consensus of the direction. They just turn in the same direction anytime. Analytically and also numerically, with tools For example, the Markov chains and the analysis of algorithms, randomized algorithms. Okay, the future research just after the baby is related to several applications. For example, predictive urban mobility, smart home services. All of them are using the prediction of the patterns of the behavior. Techniques, Bayesian techniques for NILM, opinion propagation in social networks, and preferences in inference. Some references, and thank you.